Hi everyone, welcome back to Chemistry with Cat. I'm Cat and I post little lessons every day at 9 a.m. You can subscribe to my channel to be the first to know about them, comment on what kind of lessons you want to see next, and follow me on Instagram for some memes, some cheat sheets, and the answers to the homework problems. Today we are going to be reviewing how to find mole fraction and mole percent. Let's get to it. Just like in mass percent, we're going to be doing a division here, but this time we're using the moles. So the mole fraction is the number of moles of one species divided by the total number of moles. This could be for the number of moles of one element in a compound, or this could be for one compound in a solution. The mole fraction is going to be a decimal, and then when we want to make that into a mole percent, we just multiply it by 100. The sum of all the mole fractions of a molecule or of a solution have to equal 1. The sum of the mole percents have to equal 100%. In the examples I'm going to show you today, the moles are given to us. But remember that if they don't give you the moles in the question, you're going to have to calculate it. So if they give you the mass, I'll link my video on moles, mass, and molar mass so you know how to convert mass to moles. They might also give you molecules, ions, particles, and in that case you have to use Avogadro's number to find the moles, and I will link that video here as well. For my first example, I would like us to find the mole fraction and the mole percent for carbon in glucose. My favorite molecule, C6H12O6. Glucose should also be your favorite molecule because it's sugar, and you need it to live. For mole fraction, we use the symbol X. And then we'll put a little subscript of carbon to know that we're finding the mole fraction for carbon. So we're going to do the number of moles of carbon divided by the total moles in glucose. So because this is just a fraction, we don't actually have to calculate the number of moles, we just need to know the ratio. There are 6 carbon atoms in the molecule, so we can also say there are going to be 6 moles of carbon when compared to the whole molecule. So we go 6 moles of carbon divided by the entire molecule, which is 6 plus 12 plus 6 moles. When we put that into our calculator, we get 0.25. And that is the mole fraction of carbon. Now to find the mole percent, we just have to multiply the mole fraction by 100. So mole percent equals 0.25 times 100, which equals 25%. And there is our mole fraction and our mole percent for carbon in glucose. Next, I want to show you guys an example of when they ask you for the mole fraction and mole percent of one molecule in a solution. So a mixture has 0.2356 moles of sodium chloride and 0.3564 moles of sodium nitrate. They're asking us to find the mole fraction and the mole percent of sodium chloride. Our mole fraction, X, of NaCl is going to equal the moles of NaCl, 0.2356 moles, divided by the total moles. So I'm going to have to add 0.2356 plus the moles of sodium nitrate, 0.3564 mole. That gives me 0.3980. 4 significant figures because there's 4 significant figures in the question. If you need a review of significant figures, I will link that video. The mole percent, all we do is multiply by 100, which will give us 39.80%. So this tells us that 39.80% of the mixture is the moles of sodium chloride. For today's homework question, I'm going to ask you to find the mole percent of each atom in C2H6O. So use that molecular formula to figure out your mole ratios. A good little tip once you've finished finding the mole percent of carbon, hydrogen, and oxygen is make sure they all add up to 100%. If they do, you know you did the question right. As always, the answer to this question can be found on my Instagram at chemwithcat, right when this video airs. So check that out to see if you got the right answer. If you enjoyed this quick little lesson on mole fraction and mole percent, please subscribe to my channel, like this video, and comment what you want to see next. Thanks for tuning in, and I'll see you guys next time.